Hey, good morning, guys. Now we will have, while we are waiting, I double check if you have finished doing the MC. Last time I asked you guys to do the MC from question 2 to question 8. Seven, sorry. Question 7. Question 2 to question 7. 1, 2, 3, 4, 5, 6 MC questions. For first 6 MC questions. Okay? While we're waiting, please do that now. Okay, I just opened the voting. Please put down the answer for question 2 or question 7. Simply click it as A, B, C, D, A or any one of the choices for those questions. You know where? Well, you have got a polling. Who is absent? Let me see. 譚君柔 are you here? 譚君柔 not here. Okay, as said, you have got a polling. Please put down the answer and let me know whether or not which questions you need to proceed. You need to have a further coverage or not, and which one or not. Now, after 5 minutes, I would like to check your answer. Now, I've seen somebody who have just answered. Okay, 2 minutes left. Now, as I said before, you have got a polling on the Zoom. Okay, do it now. Now, last minute. All right, so finish. Now it's time to put your answers on the MC on your survey. Okay, you know where it is. Now I'll just show you what I see here. Okay. Now we have got 11 students are not filling in anything. Now please do it now. I'll wait for you. Okay, I'll wait until here comes the majority who have voted and we will start. Have a debriefing now. Now take a look on the question. Now very authentic questions on question 2. So the answer is A. I found quite a number of you and have answered it correctly. So I will not talk too much about the calculations method. The answer is A, correct. So you are going to find out the molarity of a solution, but you are given the mass and the volume of solution. You have to change it to mole first. First of all, I would like to remind you. Second is about the volume of a solution. Please change it to dm cube before you come up with the answer. Okay, so the answer is A. Okay, question 3. The in exit, the methyl orange is red, while the phenolphthalein in exit is colorless. Okay, so the answer is D, but not red. Okay, this is what I would like to remind you. Question 4. Question 4, take a look on your choice. Most of you have got it A, correct. We have got the majority got it correct. About 67%, it is A. So how would you get to know the answer? You are going to negative log hydrogen concentration equals minus 3.4. So everything starts from this. So as you know, this one is a monobasic exit. Okay, so this is this, and now you are going to find out the hydrogen ion concentration as put a 10 minus pH. So this 10 to a power minus 3.4, and you can get the answer. The answer is A. Okay. So how about question 5? Wow, divided. So question 5 is you have got C. Now, which of foreign gases after dissolving 1 dm cube of water give a solution of highest pH? Highest pH means what? Okay, it is alkaline, right? So you check which one is alkaline. The other one, only C is alkaline. While A, B, and D won't dissolve in water, it form an exit. Now, at least you need to give me the equations. Do you know how to write down the equations here? Which tells you is it an acidic solution? Do you know? Now, for example, D is easy. Once I put it into water, it tells it undergo ionization to form hydronium ion and chloride ion. Okay, can you get what I mean? Now, leaving behind is on SO2. SO2 is SO2 dissolved in water to form what? How would say that in it is acidic. To write down H2SO3, well, H2SO3 will have an ionization to form hydrogen ion and sulfite ion. Can you get what I mean? Can you get what I mean? Okay. Could you please do the same to tell me about ammonia? Ammonia react with water to form ammonium ion and hydroxide ion. So we call that a highest pH because it gives extra supply of hydroxide ion. When you compare with the others, they will give extra supply of hydrogen ion. How about NO2? You know how to write down NO2? Now I give you some time to search in the web. Tell me how come I say NO2 is a acidic gas. Once it dissolves in water, what will be formed? Do you know it?
HNO3
HNO3 is it?
HNO3 同埋 NO 咯。
NO. Any other question? Any other choices? Now you search it on the web. NO2. Once it dissolves in water, what is the exit? When you're long, please check. Do you know? Now I'll give you some time to check this. Nitric acid. Is it nitric acid? Now could you please put down the balance equation for this? Now I give you a task, right? Go home and please check this balance equation for me. Now, because I would like to spend some more time on calculations with you, because I found the other two questions more divided. Question 6. A trout fishery is owned at limestone to its log. So the question is, the pH of water changes from pH 5 to 7. The concentration of hydrogen ion. Okay, what will happen to this? The answer is D. The answer is D. Now remember, because pH it is a log scale, it tells you a log scale. So if you have got a difference in 2 units of pH, which means that we have got a factor of 100 already. Okay, but the question is, if you are going to increase the pH, of course, the hydrogen ion concentration will be decreased. Now, because of this data, right? The higher the hydrogen ion concentration, the smaller value will be the pH. Based on these two information, you know that the answer is D. Okay, remember, it's either the concentration of hydrogen, of course, is not increased. 你唔會酸咗噶嘛？嗱 ，hydrogen ion 嘅濃度越高，即係話酸咗嘛。咁所以你答 A 同埋答 B 嘅同學咧，嗱你撈亂咗個概念啦，就係濃度 hydrogen ion 越高 ，pH value 就越低。O 唔 OK？ 咁調翻轉啦，如果 pH value 越高，即係意思咩啊 ？hydrogen ion 嘅濃度就越低咯。跟唔跟到先呢度？嗱，咁剩翻咧就係、究竟有16位同學你揀到係 decrease 㗎啦。咁但係一個咧就係話爭2倍，一個係爭100倍。咁爭啲咩咧？就睇個 log 咯。原來計數 log 咧係解緊10倍，有10㗎，有10個單位咁多嘅，得唔得？咁喺呢一度咧，喺本書入邊有冇見過呢啲圖咧 ？So you check this. Now that data that you may find here, right? So we would have got the pH from 5 to 7. 5 to 7. Can you see that? It decreased in 1,000 times. So this is what I would like to remind you. a difference in the units of pH by 1 unit, right? It will make a difference in hyaluronide concentration 10 times. Second, it's about the change in pH. Increase in pH, which means the decrease in hyaluronide concentration. Now, please circle that. I found quite a number of you got confused by this. Okay. So how you know the answer, right? Actually, from 5 to 7. So it depends on the calculations. pH equals negative log hyaluronide concentration. Okay, which means that this one, the concentration is from 10 to the power minus 5 molar, and this one to 10 to the power minus 7 molar. Okay, so here comes 1,000. 1,000 times, 100 times, sorry, 100 times smaller. Okay, you get the point. How about the last one? The last one, the answer is A or C? The answer is C, but not A. Now, if you have got confusion of this, which means that you are going to take note on the fact that the number of moles of sulfate ion should be taken into account about this, right? Can you see that? So which means that if you want to get to know number of moles of sulfate ions, which is equal to 50.0 times 10 to the power minus 3, it is volume times the molarity 0.6 plus what? 150.0 times 10 to the power minus 3 and times 0.2. But remember, 1 mole of iron 3 sulfate contains how many mole of sulfate? We have got 3 here. So you are going to put that 3 into the whole thing. And the total volume, of course, most of you have got it correct, right? 50.0 cm cube plus 150.0 cm cube. And I do think that that gives you a much difference if you are choosing A or C. Questions? Questions? 記住嗰度要乘3啊？點解？ Because 1 mole of iron 3 sulfate contains 3 mole sulfate. 有咩問？有咩問呢度？係啦，有一位同學仔冇答啊，唔緊要，我一陣間 check 翻嗰個調查，我就知邊個冇答噶啦。有一位同學冇答，尋緊有咁晏嘅喂，完咗一堂啊。Okay, so this is your survey results are very interesting, especially the calculations part. Okay, questions? Now, if not, we would like to show you today's lecture about this. Now, today our task is to get to know something more about the acids or alkalines, which tells you as strong or weak. Now, this sentence is rather confused. It will rather confuse you while you talk about it as concentration. Okay, what do I mean by that? For example, if you say that we have got 12 molar of ethanoic acid, is it a strong acid? Now, my doubt is that if you have got that concentration, we would have a hazard warning label telling you corrosive. So is it a strong acid? Now, so this is what I would like to draw attention to. These questions are very tricky one. Now, please refer to the book, page 55. 55. So what is mean by strong or weak exit? Now, strong or weak undergo the category strength of exit. 強度. Now, this concept, when you compare with concentration, is a little bit different. Okay? They are not telling you the same idea, actually. But what makes a difference, and I would like to show you animations now. And please read the animations and try to describe for me what is the difference between them. Now, first of all, I would show you a strong exit, weak exit, right? To give you an example. For example, HCl. Do you see that? Do you see this? Do you see this? Okay. Now, it is the rather not dilute or concentrate. I try to make it dilute, right? Dilute. Now, take a look on this. What do you find? Hydrogen ion and chloride ion, right? How about hydrogen chloride molecule? Where is it? You don't have it. Now, especially while you check the data inside, the number of particles in the solution, now you may find that they will have no HCl molecule. Instead, we have got hydrogen ion and chloride ion only, which is found in the solution. Okay, if I put it in a concentrated, what happens? Now take a look at this data. Now we have got a very trace amount of hydrogen chloride molecule, but most of them they have formed as ions. What is that process? We call that ionization. Now, can you see the word ionization? So it tells you the change from molecules to form ions. Okay, for that process, ionization. Okay, can you get a point? How about I change the concentration higher one? Now, the higher the concentration, what will we find? Now, you may still see most of them, most of the hydrogen chloride molecules, what happened to them? They have ionized, okay, to form hydrogen ions and chloride ions. We will call this type of exit a strong exit, which tells you it completely or highly ionized in water. So you will say that a strong exit. So that's why if your book, if you show it, it will write it down as HCl, HQ, and to form hydrogen ions and chloride ions, like this with a single arrow, which tells you the exit that ionizes almost completely in water to give hydrogen ion. Now take a look on the book. The book, they will tell you the word dissociate, right? Change it to ionize, please. Ionize. 你本書入邊嘅第50頁，見唔到個鎖匙窿啊 ？That dissociates almost completely. So change the word from dissociates. I don't want that. Use the word ionize. Can you get a point? Now I do the same thing by checking the others. How about nitric acid? Yes, we still call it as a Now we still call it as a strong acid, right? Can you see that? Now it is not the hydrogen HNO3 molecule to be the main role, right? You instead will have got an ionized form, hydrogen ion and nitric ion, right? Even though I make the solution dilute or concentrated. Can you get a point? How about with acid? Now for with acid, what do you find? Which one dominates? This is the molecular form that dominates, right? This time. CH3COOH dominates rather than the ions. Now, no matter you adjust the concentration of dilute or concentrated, can you see that? Now, even though I make it concentrated, of course, there will be more hydrogen ions and ethanoic ion. Now, however, the dominant species, this is our focus, it is still ethanoic acid molecule. Okay, so ethanoic acid is a wet acid. And what do we call it with acid? We call it the ionization is not complete. But if you talk about the degree of it, it's just a slight ionization, which means a very small percentage of the ethanoic acid molecules have ionized to form hydrogen ions and ethanoic ion. Can you get a point? So this is what we will call it as a difference between strong acid as a weak acid. Questions?
史 Sir，
係
我想問咧，咁即係話，咁其實佢如果話 define 佢係 weak acid 定係 strong acid， 係究竟係用個 percentage， 即係可能佢剩翻低個 molecule 個 percentage 去計啊，定係只要佢個 molecule 係大過佢嗰啲 ion 就已經係算係呢個 weak acid 咧
？Good question, Sam. What do you think? First of all, you try to make some clarification of the substances. First of all, any relationship between strength and concentration of acid， 究竟一個酸嘅強度同埋佢哋嘅濃度之間有咩關係？有冇呢兩樣嘢有冇關係嘅？濃度同強度之間有冇關係？答案冇關係嘅，有冇留意到啊？冇關係嘅，濃度同強度係冇關係嘅，呢個第一樣嘢要澄清咗先嘅。濃度強度冇關係。好，第二樣啦，濃度強度冇關係嗰時，我哋要 check 咩咧 ？We try to take a look to determine whether or not the acid is strong or weak. It depends on what? It depends on the degree of ionization, and that is the thing that we have to consider. Okay, what is mean by that? Now, what is mean by that? Now, I would like to go back to this. Now, take a look on the definition first. The strong acid is an acid that ionizes almost completely in the water to give hydrogen ion. How about weak acid? The weak acid is an acid that ionizes partially to give the hydrogen ions, which means that if you want to talk about strength of acid, we focus on percentage of ionization. Okay? So if you want to make the case simplified, then we have the two cases. One, 100% or almost 100%. So we will call that acid a strong one. But if you have got slight ionization, the percentage varies actually. Partially, right? You see the word partial, slight. So you will not have any in between, okay? Partial or slight. How much is it? It's just ranges from several percent, from 1% to 5 or 6, for example. If that is the case, we will call that weak acid. And it is much related to the acid nature itself. Now, can you relate which acid is said to be strong and which acid is commonly said as weak. Now, for example, mineral acid is a strong acid. 有冇人睇到啊？有冇留意到呢啲樣嘢？ Mineral acid is a strong acid. While for weak acid, you usually refer to organic acid. So what do you mean by organic acid? The one we show you COH. You usually describe as a weak acid. While for mineral acid, what is that? HCl, HNO3, H2SO4. They are the common example to tell you that acid being strong acid. The while for weak acid, commonly we will say that COH. Now, it is something related to molecules, the nature of molecule itself. Now, because you need to ionize it, you need to break the bond. While you break the bond, you need what? You need energy. Okay, can you get a point? You need energy. So this is one of the reasons to tell you why most organic acid are said to be weak acid. Can you get a point? 所以咧，你問 strength of acid 應該睇啲咩？係咪睇濃度啊？唔係嘅，我係睇強度。咁強度點睇？邊度強邊度弱啊？就係睇 degree of ionization 啦。咁如果你喺DSE 嚟講咧，我哋講嘅例子都比較極端，就係 almost complete ionization or just light ionization。如果你話我做類比嘅話咧，邊啲酸會係通常叫強酸咧？就係 mineral acid 啦。咁邊啲酸通常叫弱酸啊？就係啲 organic acid， 有 COH 嗰啲咧，其實你唔使諗啦，嗰啲都係一啲叫做弱酸嚟㗎，得唔得？咁強酸弱酸有咩分別咧？咁樣嗱，你點形容喺入邊嘅狀態咧？書入邊咧有呢啲圖畫，或者甚至乎頭先 animations 都話俾大家聽。嗱 ，which part is more dominant? So the ion part, the ion form, ionic form is more dominant, or the molecular form is more dominant, and it will help you judge whether or not the acid is said to be strong or weak. Second, it's about the presentation. Now, if you write down the strong acid and weak acid, the presentation is different, right? The weak acid, the strong acid, the presentation of that equations. To tell you the formation of hydrogen ion, right? Its ionization is by single arrow. How about this? It's by double arrow. It's by reversible sign, which will tell you the ionization not complete. It's just light ionization, which means a small fractions of the molecules ionizes to form hydrogen ions and the salts form. Can you get the point? 跟唔跟到？大好俊，知唔知我講咩
？OK， 好，唔該。
好，跟住 ，and it's not just that. Carbonic acid is a very special case, right? It's not organic acid, but it is also a weak acid because the carbonic acid that will be formed as what? Carbonic acid, they will form hydrogen ion, hydrogen carbonate ion, while hydrogen carbonate ion will further ionize this. So we will call that the first stage of ionization. But this one is the second stage of an ionization. So what is the hidden message? In the solution, you may have got the molecular form of acid, carbon dioxide itself, carbonate, hydrogen ion. Now, if you want to tell you all substances, you may have got what? Water molecules. We have got hydroxide ion as well. Can you get a point? You still have this. But this one is very, very trace amount. Very little amount. Not too much. Why? Because we still have water. Right? While water will self-ionize to form hydrogen ion and hydroxide ion. So even though you talk about acid, we still have hydroxide ion. It's something very, very strange. So remember, do not get confused about the concepts between the solution between acid and alkaline, right? You need to check difference in the concentration of hydrogen ions and hydroxide ions. questions？ 明唔明呢度發生咩事？複唔複雜喺度？ If so, if you understand what is happening, we come to the activity 15.2. Let's this one. So that is the. I need to check your web link for you. I'll just wait for me. Now this time I show you as an exit first.
Put 80 cubic centimeters of 0.1 molar hydrochloric acid into a 100 cubic centimeter beaker. Set up the apparatus as shown. Adjust the range selector of the multimeter
你睇到個
to a
video
suitable range for measuring DC current.
Do you find it?
而家有啦，而家有啦。
Record the reading immediately.
咁啊，頭先做啲咩咧？就係
Put 80 cubic centimeters of 0.1 molar hydrochloric acid into a 100 cubic centimeter beaker. Set up the apparatus as shown.
apparatus shown.
Adjust the range selector of the multimeter to a suitable range for measuring DC current.
It's just an emitter, right? But it's
Record the reading immediately.
electrical conductivity. Okay.
Take out the electrode rod holder from the beaker. Wash the carbon rods with running tap water. Empty the beaker and wash it well with water. Repeat the experiment, but using 80 cubic centimeters of 0.1 molar ethanoic acid instead. Record the reading. Which acid is more acidic?
Now, of course, you will find from the ammeter reading, you may know that the HCl is more electrically conductive. But why? Now, this HCl. Now, we have got 0.1 molar ethanoic acid and HCl as a comparison. Now, this is for making a fair test, right? The concentration of the acid is kept to be the same. Now, such that whenever there is a difference in the results, you may relate it to the nature of the acid. Okay, can you get a point? So you may find that from the data, this one is higher, this one is lower. So what is the conclusion? This one HCl is more acidic. Why? It is something related to what? There must be some reason behind, right? It is related to what? That electrical conductivity depends on what?
Mobile ions. Mobile ion.
Yep, mobile ion. Can you please elaborate on more on this? The concentration of mobile ion. The concentration of mobile ion. Yeah.
More ions deionize in a stronger acid, like
ionized, not deionized. Ionized. Ionized, yes.
And ionized in HCl, and there are more mobile ions in the HCl solution in HCl acid than the ethanol acid.
Now, if you want to talk about more mobile ions, right? So remember to try to modify the saying by saying per unit volume of the exit. What's mean by more mobile ions per unit volume of exit, which means the molarity of mobile ion is higher. Okay, remember in your DSC, we will focus on concentration of mobile ions to explain. Now, so it is due to what? It's due to this exit. It is a strong exit. Okay, which means we have got an 100 or almost complete ionization to form mobile ions. Can you get a point? And which contributes the high mobile ion concentration, and which refers to the fact that the solution is more electrically conductive. Now, how about the other case? Slight ionization. So to give less mobile ion, right? So if you want to relate the molarity as mobile ion concentration, it will be much lower. Okay, so it will explain you well why this ethane oxide is less electrically conductive. 跟唔跟到？明啊呢度？
Repeat measuring the electrical conductivity, but using 80 cubic centimeters of 0.1 molar sodium hydroxide solution instead. Record the reading.
如果揀咧有啲
Repeat the experiment, but using 80 cubic centimeters of 0.1 molar ammonia solution instead. Record the reading. Which alkaline is stronger?
which alkaline is stronger? NaOH or ammonia? 頭先呢度講咗又係0.1 molar 嘅 NaOH 啦 ，and this one is 0.1 molar ammonia. So you may see the data is much slower. So the reason is very similar, right? You got a slight ionization for ammonia. Once dissolved water, it ionizes slightly to form ammonium ion and hydroxide ion, which contributes that the mobile ion is not of that high concentration. When you compare with NaOH, NaOH we call that complete. Is it ionization? No. We will use the word dissociation. Why? Because originally NaOH is not is already an ionic form. We're trying to make the ions from immobile to mobile, so we will not have the concept ionization. Can you get the point? Now, please don't use ionization to relate the case for the strong alkaline. Now, this is the only case that you need to be highly aware of the use of words. Can you get the point? How about the other three cases? We'll use the word ionization. Now, remember the nature of the chemical. Will get you to get to know more about the word dissociation should be used, or ionization should be used. Can you get a point? It's much higher, right? The mobile ions is much higher, complete dissociation. So which means that once it dissolves water, it will totally give you sodium ion and hydroxide ion. 跟到未？咁所以導電應該要睇咩咧？就係睇mobile ion 嘅濃度嘅，得唔得？記住。If you want to take a look on the electrical conductivity, please check the difference in mobile ion concentration. 跟到未？ So we come to some other cases, some other experiments. The second one is pH.
Dip a glass rod into a little 0.1 molar hydrochloric acid in a test tube to get a drop of the solution. Apply the drop of acid to a piece of pH paper.
嗱，留意啊！嗱，有啲同學咧，即係將成張紙浸落啲酸度啊，唔係啊，調轉㗎，喺個 sample 度攞一滴落去張紙度㗎。
Match the colour of the pH paper with a colour chart. Record the pH value. Repeat the experiment, but using 0.1 molar ethanoic acid instead. Record the pH value. Which acid has a lower pH value? Repeat measuring the pH values, but using 0.1 molar sodium hydroxide solution instead. Record the pH value. Repeat the experiment, but using 0.1 molar ammonia solution instead. Record the pH value. Which alkaline has a higher pH value?
今日度啊，原來佢哋做呢個實驗咧，我哋要睇咩啊？我哋有兩個實驗做咗嘅就係、you're going to check its electrical conductivity and measure the pH, right? So I try to use exit as an example, right? You may know that for electrical conductivity, it's much related to the electrical conductivity is related to the mobility of these particles, right? In terms of concentration of mobile ion. Please circle it. Okay, so which will related to the degree of ionization. So if you want to talk about this degree of ionization of exit, they would affect the concentration of mobile ion. Okay, so it will affect our electrical conductivity of exit. Can you get the point? So this affects this, and this will affect this. Okay. How about pH? The degree of ionization of exit, it will affect what? And which will affect pH. So you know that pH is a measurement of a hydrogen ion concentration from another way around, right? So it is related to the concentration of hydrogen ions. Can you get a point? So it will tell you why for the HCl is a strong exit. It will have a full ionization or nearly complete ionization to give out hydrogen ions. In other words, the concentration of hydrogen ions in HCl is higher than that of even exit. So the pH of it is lower. 嗱，呢度佢最容易會撈亂㗎。越高濃度嘅氫離子，佢個 pH 值就越低啊，得唔得？明唔明？咁下邊係講咩？越高濃度嘅mobile ions 嘅話，佢個導電性會點啊？就越高嘅。嗱，呢兩個 terms 係要留意嘅，得唔得？佢哋個因果關係，記住你圈低呢兩個，我要你解釋嘅時跟住呢個圈呢個路途咁寫嘅。跟唔跟到？好，咁跟住仲有啦，第三個啦。咁我唔做呢兩個，咁做第三個實驗就得㗎。You are going to use reaction with magnesium, and you may find that the concentration of hydrogen ions will affect what? The effervescence speed. Now, so you see that it reacts more rapidly, but not more. 嗱，呢度要小心啲啊！你話嗱 rapid bubbling，more rapid bubbling 唔係 more bubbling，係 more rapid bubbling， 係速度，唔係講份量啊。而我哋今日係講速度 ，O 唔 OK？ 嗱，你唔好寫錯啊呢度。咁即係話呢度亦都係啦。The strength of exit 就係講緊咩啊 ？Degree of ionization of exit, they will affect what? The hydrogen ion concentration, which will affect the reaction speed, right? So, but in chemistry, they will use the word reaction rate to tell. Reaction rate. 跟唔跟到？咁點解要講 hydrogen ion 嘅？嗱 ，you take a look on the ionic equation, and you can get what I mean, right? The major species to undergo the reaction is by what? The reaction between the metal and the acid. Okay, so it depends on two things. One, the surface area of the metal. Second is the hydrogen ion concentration. And if you want to make a fair test, that magnesium strip, they should be identical in two cases. Can you get a point? So the only factor that may be changed is by hydrogen ion concentration. So in order to do the similar equation experiment like this, remember to have a concept of fair test. Again, do you understand?你明呢度我講咩？跟到啦嘛呢度。好，明嘅係咪？明嘅話咧，咁就揀啦，揀嗰度我提翻你啦。咁揀咧可唔可以用類似嘅路途咧？得㗎，但係 dissociate 呢字用得啱。with alkaline 唔得啦，就係 ionize 啊。嗱，通常 with alkaline 咩咧？一啲ammonia 嘅啫，你 DSE 就學 ammonia 嘅啫，冇其他㗎啦。係咪？但係酸咧就好多啊，但係通常都係講有機酸嗰就係 with acid 啦。So for alkaline dissolving water is dissociate fully to form sodium ion and hydroxide. But for ammonia molecules, now you see that, right? A reversible sign to form that hydroxide and ammonium ions. How does it affect in bulk? For pH, the strong alkaline, they have a higher pH. Why? Higher concentration of hydroxide ion, right? How about this? Electrical conductivity for NaOH of the equal molar, millimolar concentration, right? 0.1 molar. It is higher. Why? The mobile ion concentration is higher when you compare with ammonia. Can you get what I mean? Okay, so go back to the first question. If you have the two chemicals, the concentrated solution of a strong acid, the concentration solution of weak acid, there is the case. So concentration and molarity, a concentration of molarity or the strength, and the strength tells you different things. Concentration, it tells you the relative amount of the pure acid that is dissolved into a certain volume of water. So this is what you can control. So this is what you can control. So you may see that data, right? You can do by dilution. Starting from concentrated acid, and you can get various the acid of various concentration. How about strength? Strength, it is not that you can control. It depends on the nature of acid. So the acid nature is a strong acid. No matter you make it concentrated or dilute, it is still a strong acid. And the same thing applies when it is a weak acid. Okay, can you get a point? But still, if you want to make a concentrated acid, no matter it's strong and weak acid, we still have a considerable amount of hydrogen ion concentration inside. So we will still use corrosive label to aware the people who use it. Is that clear? Is that clear? Okay. So please please go home and check and try to do these two questions. Question 1 and 2. Question 2, it is an essay type question. So remember, fair test is the key to answer the question full. Okay. And second thing is about the question 1. Question 1 is rather difficult to explain, right? Now you try to go in reverse, right? The pH value is the same, but the concentration of acid is different. So you are going to tell me which one is the strong acid. Now we seldom think it like this model, right? We usually treat the molarity of the of acid the same, but the difference in the strength, and then use it to compare, right? So this time, this one is a little bit tricky. Do you know what is that about? Okay. Just tell me your level of understanding today. Today afternoon. Sorry to say that I need to have a meeting, okay, with the teachers to tell you what to do in the coming weeks. So we'll the supplementary lesson will have to be suspended. I want to find some more time for it. Okay. Let's tell me when we will be available. Is it tomorrow afternoon? Can we manage? Is it better if I make it tomorrow afternoon? Now, let me know in terms of the message in your WhatsApp, okay? And that's it. Okay, let's have a recess. Goodbye.